Hi, this is Angela Tagafunda. Student number is 1622426, and I'm here to talk about Lab 4, which is about bouquets and depth of field. So, to implement bouquets and depth of field, we would want to set several FBOs, one being our default scene where nothing happens, the second one for our horizontal pass, the third one for a diagonal A in whatever direction you want, then another diagonal for another direction that you want, basically. So here we just initialize those FBOs that we're gonna need. We initialize our shaders here, so we're gonna be using our bokeh shader and our bokeh composite. I'll move on to talking about that a bit later. Let me open it first. Oh no. Yeah, okay, so so moving on. So when we initialize those shaders and we bind them to our materials. So we bind our bokeh shader into our material bokeh, and we bind our bokeh composite, which is like a accumulation of all the bokeh effects that we have into another material. So here we just initialize our scene, good stuff, which is normal. So moving on to what we actually want to talk or see is that here for the bokeh pass we're gonna take two FBOs as a parameter. So an FBO to sample from. For our case we're gonna use so we're taking in two parameters, which is like a bokeh to sample to and a wait, did I explain it right? Wait. Okay, so we're gonna take three parameters, which is like a frame buffer to sample from, another frame buffer to put the sample in, and then the filter angle degree, which is like as to how the bokeh is gonna be oriented. So an angle, basically. So if you want a 90 degree or like a 45 degree, which is like slightly rotated bokeh, then you would want to put a filter degree of like 45 in it, I guess. Yeah, so here you just bind the frame buffer that we're gonna draw to, then we bind the texture that we're gonna be sampling from, and then yeah, we're good stuff. So we send in our uniforms into our bokeh material, which is what we're gonna use to actually calculate the bokeh calculations, and that bokeh shader would look like this. So we calculate our offsets here, number of samples, which is like how many times you want to sample from that actual scene. I mean, not actual scene, but yeah, how many samples that you're gonna use. So we calculate our aspect ratio, radius, and what is BT, and those stuff. And then here's our actual bokeh calculation. So it also depends with our samples that we number of samples that we want to do. So there's bleeding bias, bleeding multiplier, I guess. And then this is where we get the pixels, and here is our calculation for the offsets and those stuff. Yep. And then moving on to the rest of the code in main. So we bind the scene to a buck buffer. So we do that here, we unbind and then we clear it. And then we send the uniforms. And that's about it. So moving on to into like using those FBOs, we would want to look at our display callback function here. So we're binding the normal scene to the FBO scene buffer so that we can sample it from. So yeah, so we can sample from there. So we draw our FBO scene into our back buffer, and then we would wanna, and then this is our bokeh horizontal. So there's no angle for this one because it's gonna be a horizontal one, meaning that we don't need to tilt the way that our bokeh lighting is gonna be calculated. So we call in the bokeh pass function. So we're gonna sample from our normal scene and then we're gonna put it into our horizontal FBO. And then we draw it at the buck buffer as well. And then for the next bokeh, we're gonna be doing the same thing for the first pass. Since it's a horizontal, so we would want to sample from a scene that already has a bokeh. So for this one, we're gonna take in the FBO scene, and then we're gonna sample the normal scene and then put it onto the horizontal FBO. And then on the second pass, we're gonna sample from the horizontal FBO and put it into a diagonal FBO along with a filtering angle of 120. So it's gonna rotate the lighting sideways or maybe on the right. It depends on where you're going. But yeah, and then we bind this said buffer to the back buffer so that we can always draw it. And then same thing goes for our bokeh pass B. It just does, yeah, we just bind the FBO from the first pass and then bind it to another, and then use the use the buffer from before and then bind that result into a new one, but with like a different angle this time, and then we're gonna draw it back to the frame buffer. So yeah, that's about it. Well, here's the bokeh, I forgot. So here's the bokeh composite that we have. So you do all of the said stuff from earlier. So you do bokeh passes 3 times and using, yeah. So I can't explain the idea, but it's so easy. So there's that. Then you bind it. You unbind it. And then, oh no. Yeah, so you set the material to bokeh composite, and yeah, so you bind your material to bokeh composite, which uses the bokeh composite shader, and the shader will just add your 2 scenes together. So in this case, it's gonna add our our passes for bokeh, and then just puts it into one bokeh scene. Or yeah, pretty much. And then pass on the uniforms and we draw it. That's about it. And the final result will look like this. Let's run it. I can't explain. Oh no. Yeah, so the final result will look like this. So this is the default. So we're gonna sample from the scene originally in order to implement a bokeh. So the first pass for bokeh for the horizontal will look like this. So yeah, that's what it looked like for horizontal, and then this is gonna be the bokeh 120, and then this is gonna be the bokeh B for negative 120, and then adding adding bokeh A and bokeh B together would result to this one, which would look like a more realistic blurring effect for depth of field. So the reason why the scene looks like this is because we slightly increased the aperture. How do you say it? Aperture. The A word. Aperture. What? Aperture. Aperture of our calculation in our shader. So this is what would it look like with an increased aperture of with a value of 5. But if you have the aperture of, like, let's say a 1, or wait, it's fuck, it would calculate it. It would, I mean, our bokeh would look like this. Because, like, basically what aperture is that it's like our eyes. So depending on how much light it is, the hole in our eye gets smaller. So if our aperture is big, then that means that the blurriness of this, I mean, the ray of light would need, I mean, there would be more light coming in to your eye, and that would just, yeah, so that would just make the blurriness, I guess, more apparent, because there's more light coming through on the thing that is being blurred in the background, or depending on the depth. So this is an aperture of like 0.06. So if you look, if you see the difference between this and what it is before, then it would be pretty apparent to then the blurring would be more apparent for a higher value of aperture, because there's more light coming in, shining through your eye, which affects how the object is blurred. So this is a bokeh horizontal, this is our diagonal, and then there's a diagonal B, and then a composite of that would result to this one. I mean, it would be less blurry having a lower aperture, but depending on what you would wanna achieve, then you can adjust it for as what you